Apparently these Rust nutters just can't let up, so I made a video really quickly the other day about how some Rust guy was trying to use after free errors as some kind of big gotcha, when in the simpler case, you do just track the thing that you're using. If the variable that it's stored in is not null, then it's allocated. And when you're done with it, you deallocate it and you set the variable to null, and before you touch it, you check the variable for null. It's very simple. So, of course, we have to stray into more complicated territory, because you can't really make a case if you can't make it complicated so that you've got some sort of excuse. So, apparently, the problem is not that. The problem is, well, what if you make copies of the thing? What if you make copies of the pointer, and then you have all these other things that are using the copies of the pointer? Guys, this is not difficult. You do not need an entire language made to baby you in this regard. It's pretty straightforward. See, in threading, you grab a mutex, okay? A synchronization primitive called a mutex. This is like 101 first day how you use POSIX threads, or any threads really. You grab a mutex for the resource, you increment or decrement based on whether or not you are using it or are done using it, and then you let it go. This works with single-threaded stuff where you just call separate functions that might touch a thing. This works with multi-threaded stuff where you have a whole bunch of different functions potentially running all at the same time on a bunch of different cores that try to touch the same thing. There's a resource, and I lock the counter for the resource, the use counter, and I increment it because now I'm going to be using it as well. And then, if you've got 32 threads that are all touching this table, then 32 threads, it's 32. And once that gets down to 0, then it's safe to deallocate it. Then you clean it up. This is what higher level languages that are interpreted or byte-coded or whatever, like Java, this is what they do internally. They have these sort of reference counters, like what's touching this, what's not, and when something gets freed up, when something is no longer being touched by anything, we can garbage collect it. We can let it go. That's how you do things. That's pretty straightforward stuff. This is really early stuff that you would learn if you get into any kind of multi-threaded applications. If you're in a simple single-threaded application where everything is being executed in sequence, it's a procedure, and you can follow the flow mentally, it's pretty straightforward to just be like, and at the end, where, for example, if I open a directory, and I go through the directory, and I'm done going through the directory, I close the directory. Or if I allocate memory to store the directory entries, once I'm done with all the directory entries and I just don't need them anymore, I free it. If I have 16 threads going through the directory entries, I wait for all the threads to exit, and then I can deallocate it because they're all done. They're closed. They don't need it anymore. Things like that. This somehow is difficult. And I think what's going on is that they're intentionally making it difficult. They're being obtuse. I think what I'm really learning is that I've been very charitable in that I go, Rust the language isn't a problem. It's this cult that uses Rust as a hammer to beat people over the head with that's the problem. But based on these comments that I keep getting, these big, long-winded comments that can't seem to understand use after free bugs are pretty easy to avoid, even in multi-threaded stuff, and trying to make all these excuses for, no, it's actually really great that the language does all that for you. Okay, but you could have just done it in C if you knew how to program in C. What I'm being told is that they actually are midwit programmers. They really don't understand what's going on. They need Rust to protect them from themselves, because they're kind of stupid. They're not stupid, they're kind of stupid. Everybody has their stupid moments. God knows I've got my fair share. I've got a project that was my first POSIX threading thing that I still haven't fixed to this day because it's not actually important. You know, we all make mistakes as we learn and grow. But I'm starting to think Rust programmers really are just kind of stupid. I'm sorry. And I know that's an emotional argument, doesn't hold any actual logical weight, but the thing is, at the end of the day, you guys are the ones that are worried about your image. I just think that a lot of you are being pricks, and when you show up and go, I'm going to defend the language that I'm using to be a prick by saying that your language sucks because it's not as good because of this thing that makes it so I don't have to do my job properly, Come on, dude. At least fall back on buffer overflows. You can at least make a solid argument that buffer overflows are a big problem that isn't easily solved in C without really careful tracking. Then again, you could just do everything in Rust and knock out Cloudflare again. I know that's not the best example, but I still think it's funny. Oh, you midwit idiots.